All right, let's get started. So today, can everyone hear me? Yeah? Awesome, cool. Awesome. How was everyone's weekend? Happy Monday. It's an 11:30 lecture, so hopefully you got to wake up on your own schedule instead of a 10 a.m. class. So hopefully everybody's up and excited about learning about algorithms today. How was everyone's weekend? I know that theoretically everyone's been quarantining and doing a good job of staying at home. If you haven't, please make sure you do that. But for those of you who have been staying at home, how was your weekend? So specifically, what have you been doing to keep occupied? Like, what about board games you've been playing? What about, video games, books, TV? Any suggestions? Meditation, that's awesome. I'm really happy to hear people are meditating. Chess, that's great. I've been playing a lot of online chess now. Like, I love playing chess, and my chess usage has gone up. I play a lot of Dominion now, so that's been a lot of stuff. Borderlands, I still haven't played Borderlands or Call of Duty Warzone. Feel like those would be cool games, but I don't have the right devices for those. Yep, so Bunny Day is coming up. So someone is talking about some Animal Crossing, maybe some eggs. Um, I, Here's a hot take. I don't love the Bunny Day so far. Like, I think it's a little too much. I'm like a little annoyed by how many eggs there are everywhere. Yeah, I don't. A lot of people I know really like the Bunny Day, but like I don't like it that much at all. But you know, it is what it is. And I also read this funny article about Animal Crossing specifically, where it said, if if it were for any other time ever, people would be so pissed off about Animal Crossing and its lack of good multiplayer play. But like right now, no one has anything better to do than like stare at their screen for half an hour waiting for multiplayer to load. So like this is the only case where like Animal Crossing would actually be successful. So apparently they got super lucky. I don't know too much about it. I haven't played, but my girlfriend plays a lot. So like it's been fun watching her and some of my other friends play. It's really funny just like being an outsider to all of the craze. The other stuff that's been interesting is I played Secret Hitler yesterday, which is this board game. It's like mafia style or werewolf style, where it's like a deception based group party game. But we played it on Zoom, so that was really cool. Like there was a website where you can play Secret Hitler. It sets everything up for you, and that was a lot of fun. I actually already put it in the random chat, so I really recommend it if you were ever into Secret Hitler or you think that would be cool. You can play it online. So it's in the random chat. If you want to play with some friends, I'd be down. If y'all want to play, hit me up. I'd be down to play with some of my students. That would be super fun too. So yeah, just let me know and we can get that started too. Cool. Oh, and then we played Cards Against Humanity online. It's called like I forgot the name of it, but I'll find it online, and you can play Cards Against Humanity online. And that worked pretty well as well. So those were the two games that worked really well online that I was super happy with. Cool. Let's jump into lecture. So today's lecture is going to be outside the world of algorithms for a sec. We're going to take a hot second to jump outside of algorithms. Some people are happy about that. Some people might not be. I know a lot of people love that stuff. But yeah, so today we're going to be taking a step away from algorithms and talking about debugging and testing. Um, Before we get started on that, I want to make a few announcements. Firstly, please stop asking me why, like, you went on to my lecture, like, you went on to my link right now and you're not seeing the lecture, like, the link's not available. Please stop asking if we have lecture on a certain day. It's on the schedule. I've already told you to put it on the calendar. It's in the syllabus. Please check the syllabus before you message me asking if we have lecture. From now on, if you ask if we have lecture, the response is going to be, have you checked the syllabus? And I don't want us to be in this spot where I have to teach you how to put things in a syllabus, in a schedule. I think that You guys are all old enough to maintain your own schedules, so please make sure that you're maintaining your own schedules. There's 10 lectures left after this one, so just take 3 minutes right now and put it in your personal calendars. Another announcement, recitations are not optional. You still have to go to your regular recitations for attendance credit. Because that wasn't made clear and because I didn't say that in the syllabus, we'll just give you recitation credit for the last 2 weeks. But going forward, we will be taking recitation attendance, and it's going to be important that you show up for recitations. They are not optional, they will be for credit, and they're worth more credit now than they were for the first half of the class. So please go to recitations, please go to lectures. There are no longer any excuses if you miss those, so don't miss them. Today's daily quiz on that note is going to be to upload a screenshot of a picture of your planner, either your like physical planner or Google Calendar, something like that. Just upload it and prove that you have all 10 remaining lecture dates added to your calendar and you've marked which ones are required for your section. That's the daily quiz, so make sure you do that today. It's going to be super important that everyone does that. Shoot, I forgot to upload the daily quiz submission still. So any of my TAs who are in the call, so maybe Kevin, if you could go through and actually upload that, or Laksha, you two can coordinate. If someone can upload a submission link for all 3 sections right now, that would be super helpful. But yeah, today's daily quiz is going to be to prove that you have it in your calendar somehow. So make sure to do that. If you haven't done your lecture quizzes for all of your lectures so far, except for the guest lecture, please finish them and turn them in. The guest lecture, everyone's going to get 100 for attending, even if you decided not to attend. But the other ones, lectures 16, 17, and 18, you have to do your daily quizzes in order to get credit. We'll give you the credit this one time as a one-time favor, if you do it now and turn it in now. But if you don't finish them by, I don't know, tomorrow at 11:59 p.m., you get a 0 on all of those. So don't do that. Turn them in now, turn in your daily quizzes right after this lecture, just go through and do them. It's not that hard and it's a lot of points in this class. I'm making this class like much easier by making it so that you get 25% of your class points by just showing up. Like if you just show up to lectures and do your daily quizzes, you're going to get a 25% at least in the class. That's a lot of free points that I'm giving out. Just make sure you do that. Today's daily quiz and every daily quiz starting today is going to be due Tuesday or 24 hours after at midnight, 24 hours after. So today's daily quiz is going to be due Tuesday by 11:59 p.m. So make sure you do that. Project 2 is due tonight, so make sure you're ready for code review. Code review instructions will be uploaded soon. I'm just gonna make sure that you have the right matches of like who you're responsible for code reviewing and stuff. For those of you who haven't finished Project 2, upload what you have onto GitHub, because if you don't upload anything, you're not gonna get points for code review, and that's not gonna be good. So just upload what you have, even if it's like 100 or 200 lines of code, that's fine, just upload it. And then someone can code review whatever code you have. So I'll give you more instructions on that. David, yes, I am going to match you with people to code review. You don't get to choose. The reason behind that is just like, if I let you choose, there's going to be people who don't get any code reviews, and that's not fair to them. So everyone's going to be given 3 people. Actually, everyone's going to be given 3 people to do required code review for. And if you do code review for all 8 people, then you will get extra credit for that. So I will also be matching you with 8 people. 8 people are optional, 3 people are required. Make sense? Cool. Any questions on any of those announcements? Where can we find recorded lectures? Oh, I will put a link on Canvas, but it is on YouTube basically. So I will put the link to the YouTube on Canvas basically. Great question, Tim. That's a great note for me. TAs, if you could do that, then that would be helpful too. There's going to be a YouTube link, and I'll make sure to share that out as well. Tim, if you could message me on Slack just as a reminder, that would be really helpful. Cool. Awesome. So any questions on any of those announcements? One more thing, homework 3 has been graded. The class in general didn't do that well. So don't be too worried if you got a bad grade or something. It's just one homework assignment. But do read over your solutions and my solutions. I annotated all of them, and I'm gonna try to pass them all back to you somehow. I don't know how to pass it back yet, but I'm gonna figure it out. And I'm going to send you back your solutions along with the grades. If you have a problem with the grades, reach out to me directly. The TAs didn't grade them, I did. So you can reach out to me about that. And then, yeah, if you don't have a grade for it, just let me know. I probably, like, if you turned it in on time and I haven't graded it, that was a mistake. If you turn it in late and I haven't graded it, that's because I just haven't gotten around to it yet. But I will get to it soon. Just message me on Slack about that. But I will be returning your homework 3 grades. Don't worry if the solutions are wrong. Like, there were 3 or 4 errors in the solutions to homework 3. Don't worry about that. Some of the problems, my solutions were wrong, and I found that out. Yeah, Alan, you can hand it in as however you want. 2 screenshots is totally fine. Yep. Cool. Let's go ahead into our objectives. So today's objectives are about debugging and testing. So you will be able to understand effectively the code that you're unfamiliar with by tracing the state of your different variables and methods and where you are in a program's execution. You will be able to trace bugs in your code using breakpoints and stack traces. That's actually going to be number 2. So we're going to use breakpoints and stack traces. And then lastly, you'll be able to convince yourself and others that the code you're doing and writing is working as intended. Instead of just claiming it, you'll be able to prove it. So this is what we're going to do in class. The first question I have, obviously, is why do we care? Raise your hands. Anybody have any thoughts on why we care about testing and debugging? All right, Yevgeny?
Because it makes development process more efficient.
Okay, how does it make development more efficient?
Well, like any code, we always have bugs in code. It's impossible to write one without it. So in order to find bugs, we use the debugger.
Yeah, so there's 2 parts to this. The testing makes it so that you don't introduce bugs unnecessarily. Obviously, we're not perfect. There are going to be bugs that fall through our gaps in our testing. So you're definitely right. Testing is going to help reduce the bugs. And effective debugging is going to make it so that we can find and address those bugs more easily. We can find them, and then we can trace them down and fix them more easily if we have the right techniques. Absolutely.
It also helped me a lot in project 2, by the way.
Great. So for those of you who don't know, Yevgeny and I actually, in project 1, he came to my office hours. I taught him how to do the techniques that we are going to talk about in lecture. And apparently it's been very helpful for him using those techniques to trace bugs in project 2 as well. So I'm glad to hear that. There's living proof apparently that that does help. So that is helpful. Cool. So let's get started and talk about let's go over my answers here. So one of the most important skills that you can develop is the ability to read and, more importantly, contribute code to unfamiliar code bases quickly and efficiently. So I don't want to be in this spot where I'm only familiar with code that I've written. A lot of a lot of the work that you've done in this class is just you writing an entire code base from scratch. So projects 1 and 2 were like several thousand lines of code for certain people, but you are writing it all from scratch, which is significantly easier than what you're going to have access to in real life, which is all these people have written code and you have to add on to it and understand all of their code easily and quickly and efficiently. And then also being convinced that others, that being convinced yourself, and less importantly, convincing others that your code works is at least as important as writing good code yourself. So if you write correct code and then you say, I think it works, or I know it works, just trust me. I'm really good at my job, just trust me, it's bug free. No one's gonna buy that. It's not real. It's like no one has that I've ever experienced has written code perfectly, correctly, every single time, all the time. That's just not an expectation. So that's why we write tests, to convince ourselves that our code works. And then this is another preview lecture of what you might see in CS 490. So CS 490, for those of you who don't know yet, is going to be taught by a Facebook EIR next semester and the semester after that. So if you're taking it, for those of you who are juniors right now, if you are taking it next year, you will be taking it with a Facebook EIR. There's going to be huge changes to the class. It's probably going to be in React or something. So there's going to be big changes and it's going to be very software related. So this is a preview of what you might see in the lecture. If you don't like this lecture, please give me feedback. This is going to be the first lecture in the series of lectures for 490. So like, I want to make sure that whatever we do here works out correctly. And then if you do like it, give me that feedback as well. To be clear, I don't know if I'm teaching 490 yet. I'll probably have a decision in the next couple of weeks, but either way, it's going to be a Facebook EIR. So, yep, cool. So the partner exercise that I have for partner exercise 1 is, how did you debug issues that you had with projects 1 and 2? And then the second question is how you would debug issues in a brand new code base that you've never seen before. So take 2 minutes, discuss this with your partners, and let's jump back to it in a sec. A code base is just a set of classes, a set of code, like a set of files that accomplish something. So like, how would you debug issues in code that you've never seen before? You can just substitute the word code there. Yes, pre-existing code. Okay. I'm gonna call on a few people. Devani, are you with me? If you are, would you mind answering this question?
I mostly go through and check what kind of error I have, and I put like different print statements to like see to see like what's going on like behind my code and like where it might be, and then like I just like trace back and see like what might have caused it, or like what I can do to like just change that output.
Perfect. Yeah. So Devani said that she uses a lot of print statements. She reads through her code, figures out where there might be an issue, and then she puts a print statement there, figures out what went wrong with what she expects versus what is actually happening, and then figures out where the bug is by working backwards, basically. And then Nick Patterson, do you have any thoughts on that as well? He just sent me a message. I can read it out loud. During the code, I usually run through it independently to ensure each part of my code works independently before adding more to it. And I use -i or compilers depending on the code to find any issues within the code itself. I don't know what -i or compilers means, but that's totally fine. The other part is making sure that your code works independent of other parts. So these are two very, very important points that we're going to talk about. Firstly, oh, it's -L for PHP. Okay, cool. So One thing that we're going to be talking about is how we're going to be convinced that separate parts of our code work in isolation from each other. And then once we've been able to convince ourselves of that, it should be easier to find bugs. The second part, which is what Devani mentioned, was working backwards and basically starting from some set of code and then saying, cool, this is what we have access to, and this is how we're going to isolate the lines of code that are probably responsible for the bug. Great answers. I'm going to draw this into an industry scenario, which is basically that happens to me pretty much every day when I'm working at Facebook. You're thrown into a brand new code base that you've never seen before, and you want to figure out what it's doing and how to use it in less than an hour. So like this is code that you have no idea how it works, what it's doing. You really don't know anything about it, but you have to use it. You know that you have to use it, and you want to figure out how to do it in an hour. How would you do it? All you know is where the main function is being triggered, but nothing else about the code. Tim mentioned that comments are really cool. Comments are cool, but surprisingly, in most industries or at most companies I've worked at, you don't generally leave many comments in code. The reason behind that is there's actually a book called Effective Java where the author talks about how if you need comments in your code, that means your code isn't that readable to begin with, and you have to explain what your code is doing. If you have to explain what your code is doing, you should probably rewrite your code so that it's more easy to read. The other thing to keep in mind about comments is, let's say you change your method at some point. Now you have to update your comments. If someone doesn't update their comment after changing your code, now everything's out of sync and people are going to be confused. So the easier thing to do is just kill the comments all the way and then just comment to explain edge cases or something like that. Don't explain the actual execution of a program through comments. Do it through better naming conventions, stuff like that. That's the industry scenario, so that's what we usually do. So I would try to stay away from commenting if you can and try to make sure you're writing cleaner code. If that's not an option, then figure out why you can't write cleaner code. It should be an option. So today's lecture is going to be how we're going to figure out, like, using no knowledge. All you know is where the entry to a code is, like the entry point to a code is, but you don't know anything else. Figure out what you need to know about where the code you need to insert is, what you need to know about the code is. So really quick, let's look at this code. So this is 2 columns. I really apologize for that. So it's going to be this function called getView. What does this code do? Let's just read through it for a couple minutes or 30 seconds maybe and figure out what this code does. Any thoughts? Get a view of something. And what do we do with that view, Ananya? Yeah, it's like a view of a city. What is a view? We don't even know what a view is, right? Okay, it looks like front end code. Yeah, it looks like front end code, maybe because we have like some images that we're loading. There's some fonts that we're loading right here, like font tangerine bold or something. There's some descriptions we're loading, images we're loading. I don't know. Yeah, Dorian identified something really interesting. This is Android app code, and in fact, this is app code from my GitHub. So this is an actual app that I wrote for an interview or something, and this is Android code. So yeah, it's front-end Android code, and it's basically setting some different parameters inside of a view. It doesn't really matter what it's doing. It's setting a name, a description, an image, a URL, different things about a view. So this obviously isn't super reflective of real life because you're not going to see too many, you're not going to see in any real life thing where I just give you code on a slide that you can't interact with and I ask, what does it do? It was a bit of a trick question, but you're usually in industry going to be given some context. You're going to be able to see where this is being called and you're going to be able to debug in some way by being able to look through this code, maybe setting print statements, maybe isolating different bugs or whatever. So how would we start understanding what this code does? Again, we can set print statements, or we can use something else, which is almost unanimously going to be a better technique than setting print statements. So today we are going to be talking about how we're going to use the built-in debugger in order to trace bugs and also learn more about the code that we're writing. So really quickly, what does this button do? I've already answered it, but has anyone used this button before? Raise your hand if you've used this button. All right, I see 4, 7-ish hands up. Okay, I see a decent amount of hands up. Cool. Let's make sure that for the majority of us in this class, the vast majority of us, we actually do learn how to do this. You can raise your hand using Alt-Y or Option-Y. Cool. But yeah, I'm gonna lower everyone's hands really quickly. For those of you who haven't used these functions, that is going to be the point of today's lecture. So today's lecture is going to be all about this magic button, this bug button that we have, and it's called the debugger. So the debugger is one of the most powerful ways to figure out what your code is doing and to trace bugs in your code step by step. So this is called the step-by-step debugger, and it temporarily pauses the execution of your program until you tell it to keep going. Does anybody understand what that means? Temporarily pausing the execution of your program until you tell it to keep going. Any thoughts about that? All right, David, you want to explain what that means?
Okay, so every instruction does something, and then we might want to see what the result of our local and global variables are after that execution is complete. But we don't want the next instructions to execute yet.
Absolutely. So after every instruction, so an instruction is just a line of code. After every instruction has been executed, so after a line of code has been run, you're going to have a state that your computer is holding. So inside of that state, it might be the state of what methods would return, what variables are currently holding, what classes are holding, what classes exist, which classes are null. There's going to be all these states within your program that the debugger is holding, or sorry, your program is holding. The computer is going to be holding all of these different states. The debugger gives you visibility into what the state of all of those things are, and it lets you trace bugs by looking at what you expect it to look like and what it actually looks like on every single level. Now, the importance of this over print statements is you can do this at any time. Print statements are a little confusing to use because you need to reload, you need to rerun the program. And if you don't have the right kind of print statements, it's just going to tell you where that code has run and how many times, maybe what the variables look like, but you have to do that manually instead of efficiently and letting the computer do the work for you. So that's what today's lecture is going to be about, using this debugger to avoid having to use print statements to necessarily debug your code. I'm not saying that you're never going to have to write a print statement again, but we'll come pretty damn close. So the first part of today's lecture is going to focus on how to use that button to understand your code easily and efficiently. Print statements also won't work if you only have an executable. Yeah, that's true as well, for sure. Will, what's up? How does this work with the event loop and stuff? What is an event loop? I have no idea what that is. This applies to any language. Yeah, as sorry about that, Will. I'll look up what the event loop is if you message me on Slack, and I can follow up with you. Cool. This does apply to every language. The terminology is all the same. It might look different. Sometimes you have to do this on the command line, but you should be able to use a debugger in any major language. Of course, there's going to be random languages that don't support it, but those aren't going to be any of the languages that y'all have written in my class. So C++, Python, Java, Perl, PHP, Hack, JavaScript, all of them support debugging, and it's going to be important. One thing to keep in mind is this is only on execution-based languages. So things like markup, like HTML and CSS, this will not work for, because that doesn't execute anything. That just lays out a template of what something is going to look like. It's not actually executing lines of code. So it won't work in HTML or CSS, but it'll work in actual executable languages. So all those languages I named are executables, basically. Cool. So let's go and talk about some key terms in debugging. So this is going to be super important, and we're going to run through an example. So this button right here means that we can step over the current line of code, which means we can pause execution at the next line. So if you say step over once you've paused execution, you say run the current line of code and then pause at the next line. Run one single line of code, basically. Step into means step into the method that's being called so that you can see what's happening internally within that method. You have this play button, which continues execution until the next breakpoint, basically. Adding a breakpoint means that you're putting this red dot somewhere, and it says pause execution as soon as you hit this line of code. Every time you hit line 515, stop executing the lines of code. Just stop the execution of the program and pause it at that line of code so that you can check out what those state variables look like. This button is mute breakpoints. Make it so that none of your breakpoints do anything until you re-enable them. If you're confused about this, don't worry. We're actually going to run through an example right now. But these are the 5 key things that we're going to be using as part of our debugging exercise. And speaking of the debugging exercise, here's the source that we're going to use today. So you don't have to actually go there right now. This is just giving credit where it's due. So Alicia was my guest speaker, and I'm going to be using some of her code today to do a debugging exercise. Her code did work, and you can use that as a solutions guide after this lecture if you want. But I've introduced some random bugs in there, and it's a Tetris program, and I've introduced bugs, and we're going to trace through using a debugger and debugging methods to figure out how to find those bugs. So I'm going to stop a share and do a new share now. Also, one quick thing, I'm going to ask anybody who's on video to stop their video because it's going to clog up some video for everyone else. But I'm going to share my screen again, sorry. Okay. So I am running through PyCharm, which is an IDE I downloaded 2 days ago. I've never heard of PyCharm before. We used to use idle back in my day, hundreds of years ago when I learned how to program. But now we use PyCharm, which apparently is a cool new IDE. I've never used it, and the reason I'm using a new one is because I want to prove that you don't have to be familiar with an IDE necessarily in order to use these debugging techniques. So I've never used PyCharm before, and this is going to be my first time. So really quickly, I'm going to, actually I'm going to do a new share one more time, and I'm just going to share my entire screen. Okay, cool. So really quickly, I'm going to run this code. Before we do anything else, let's just play some Tetris and see what happens. All right, I got this eye shape, and I'm playing Tetris, and the goal of Tetris, for those of you who don't know, is to clear lines that are complete. Okay, I keep getting an eye shape. This is very odd. Maybe it's just a coincidence that I keep getting eye shapes. Now I'm less convinced that it's a coincidence. I got 7 eye shapes in a row and nothing else. The chances of that are probably less than 1%. So I'm really not convinced that that's working as intended. The other thing is we cleared this row right here, and then we got some crazy crash here. So that's not great. So let's make note of that somewhere. So I'm going to open up my Notes app really quickly, and I'm going to go through and make 2 different notes. So the first note is going to be that I'm only getting I shape. And then what's actually 0 in newer versions? And then the second bug that I want to fix is that lines are not clearing properly. Okay. Yeah, I mean, this is just someone's version of Tetris that they wrote, so it's not necessarily like a versioning thing, but it's pretty much 0 for all it is. Yeah, and PyCharm is a Python IDE basically, which helps me handle and debug Python code a lot easier. So cool. So these are the bugs that we want to fix. The lines are not clearing properly, and I'm only getting an I shape. So this is code that theoretically I've never read before. Obviously, I've read it before because I was preparing this lecture. But we're going to go through this process. I've only read this code for like 10 minutes, maybe maximum. So I'm not like intimately familiar with it or anything like that. Another thing I want to note is, no offense to Alicia, but this was code she wrote 4 years ago, and it's really bad code. Do not look at this code as the example of what the best code is. We have classes that are written inside of like one Python file. Each class should have its own file. This is like, let's see, this is 600 lines of code basically in one line, in like one file. Not great. This isn't the best code ever, but I'm just using this because it's a new file in a new program that we're all familiar with, hopefully. So a couple things here. When we open up this project directory, we see 2 PNGs. Let's open up these PNGs. Let's see what they are. Cool. They're just like actual screenshots of playing execution, basically. So we don't really care too much about that. It says README. Let's read through it. It says this is based on OCW. She's coded this based on an MIT course. Doesn't really matter. We don't really care. We just want to find the bugs right now. So let's close that. Now we see graphics.py and Tetris main.py. Graphics.py, it says it's a simple object-oriented graphics library. It's designed by this person and it's open source. All right, I'm gonna say right off the bat, this is probably not code that she wrote. This is probably just some open source graphics library that she found, and she just copied it in. Probably not where our bugs are. So let's just ignore graphics.py. Let's just take a look at Tetris main.py. Anybody else see anything else here that's interesting? I don't think so. Only Tetris main looks interesting. Sorry. All right, so let's read through this code before we do anything. This is always my first step. Let's just read through it and be a little familiar with it. So we see this class block, and then we see a class shape. Has a lot of methods inside of it. There's an I shape, there's an L shape, an O shape, an S shape, a T shape, Z shape, bunch of different shapes. Doesn't matter what they are, what they do, there's just a bunch of different Tetris shapes. There's also a class board, and it represents the entire Tetris board. So there's an init, obviously, because it's a class method. It lets you draw a shape. It figures out if you can move a shape. It adds shapes, deletes rows, is complete. Aha, okay. So we already saw that lines are not clearing properly. So maybe this is problematic. So we see delete row. Just assuming based on the name of this, this is probably what clears a row once it's done. So maybe this is problematic. I'm just going to make a note of that. I'm not even going to read the code right now. Let's just say this might be problematic. I usually say something like to do straight just so that I can find it more easily. All right, let's keep going. Is row complete? Move down rows, remove complete rows, and game over. Cool. And then there's a whole bunch of stuff here. Create new shape, which creates a random new shape. Aha, okay. So this seems like this could be problematic as well. So maybe creating the new shape is going wrong as well. And then we have animate shapes, do move, do rotate, a bunch of stuff. Davin said random int 0 to 0. Yeah, something weird's going on. Let's just see what happens here. Cool. Then there's key press logic, and then we actually start the game. So game equals Tetris win loop here. Sounds good. So let's get started with actually debugging this. So firstly, let's end the execution. This stop says that we're going to kill the game, basically. And then we're gonna go here, and let's just say we want to start execution. We just want to start the breakpoint. We want to put a breakpoint to stop execution as soon as we want to start playing Tetris. So if we press this, just as an exercise, this isn't going to actually stop any execution because this just runs the program. See how it actually didn't stop anything? Now let's try doing this. Debug Tetris main. It immediately stopped right here. Aha. So we've set a breakpoint here at Tetris win, which means that we're immediately stopping execution as soon as this line of code is reached. And we see all these crazy things here. We see bad option, default config, obj already drawn, win here, like all kinds of crazy stuff that we want to be able to see. There's also special variables. Like, look how amazing this is. We can see what the S shape holds in it. We can see what blocks there are. There's just a whole bunch of crazy crap that you're gonna see in here that you might not have seen if you were just writing print statements. This gives you a holistic view into the entire system instead of just one line. So again, we can go and actually say that we want to step over, which means that we execute line 588 and go to line 589. So let's try doing that. Okay. So now Tetris has actually started, and now it stops execution at win.main loop. Another thing that we can do is say, resume program. Just keep going until we hit another breakpoint. So let's resume that. Now there's no other breakpoints, so we're just resuming execution. This is a bug in the Python debugger, but now I actually have no control over input. So we can't really do anything. I'm gonna restart it now. So let's keep going. Now we can do things. So I can play Tetris. Again, this is problematic that this breaks here. Okay, cool. So now let's figure out how we can actually find out where this bug comes from. So if we run it one more time, then we stop execution here, and we don't want to step over it. We want to figure out what is actually happening. So we have two options. We can step into, or we can step into my code. Step into my code is going to be the preference most of the time. It basically says, don't step into things that are system code, just step into my actual code. The next line of code, that is my code that I wrote. So here we go. We see self.board equals that. So these are just initialization variables. All of this looks fine, so I'm just gonna step over them. So we're doing this, and then we say self.current shape equals create new shape. So at this point, we're stopped on line 504. So let's go in here and say, what is self.current shape? It's an I shape. That's exactly what we expect. It's always I shape for some reason. So maybe that's the problem. So let's just start from the top and say, now that we have this create new shape, maybe that's where the problem is. And we already set a breakpoint there. So let's run it in debug mode one more time and say, aha, now we're gonna stop at create new shape. Now, do we want to step over or step into this code? Into. Why do we want to step into this code? That's where the problem is. Yeah, exactly. We just know that there's some problem that might be inside of here. We don't know that it's in there. We just know that it might be in there. So let's step into it. So we step here and we say random shape equals random.randint 0 to 0. All right, first of all, there's a red flag right there. If I see some hard-coded numbers, generally you're not supposed to see hard-coded numbers, period, in code. So either this is badly written code or there might be a bug here. Like someone was testing something and then they forgot to revert it or something like that. And we already made a note saying to do, is this problematic? Aha. So this seems promising. So random here, random shape is going to be always 0. So let's step over this. So random shape is 0. And then we say self.shapes random shape. So this is the beauty of the debugger. We're going to open up self here. So see this thing, this pane called variables? We're going to open up self. We're going to open up shapes. And then we know random shape is 0. So we're going to open up the 0th shape here. And then we see that this is an I shape. Now, what is this like weird parentheses happening here? In order to check on that, we have to go into the I shape class. So let's go into the I shape class. And we can set this in a debugger, or we can do this manually. For this purpose, I'm just going to look at it manually and search for I shape. Aha, so we say that the init basically takes in center here, which is presumably some tuple holding x values and y values. And then it says that that is the center of where the actual block is. So going back to our code where we executed it, we are passing in board.width divided by 2 and 0. So the x value is board.width by 2 and the y value is 0. So what does that represent? Anybody have any ideas on what board.width by 2 and 0 might represent in Tetris? Raise your hands. The center, yeah, center is board.width divided by 2 for sure. What about that 0? Why is it 0 for the, yeah, bottom is usually where y is going to be. But we know that it's going to be at the top based on how the program executes. So we can make an assumption based on what this 0 means. So we can assume it's a computer coordinate, like Liam said, and not a human coordinate, where y grows larger as you go down the screen. So 0 is at the very top, and x, where board.width divided by 2, that means it's in the middle top of your entire screen. Great job. So we already know what the bug is right now. We see that it's always going to take the I shape and make a new I shape starting at the center at the top of the screen. So someone want to go in here and help me fix this line of code? What should random shape actually be here? Instead of 0, what should we do here? How many shapes are there? How can we figure that out? How can we, what if we want to add a T shape? What if we want to do that? Maybe we should do self.shapes.length. Okay. All right. So we have self.shapes.length. Length doesn't seem right there. Let's try length here in Python. So let's do that. Okay. Length self.shapes. So does that seem right? Random shape equals length self.shapes. Is that right? Should we run this code and see what happens? Okay, let's run this code. Oh, Arthi is saying we still need random. Okay, so let's do random then. So we're doing a random.randint. Random.randint is inclusive of both points, correct? So we can do random.randint of 0 to 7. Well, we already have length self.shapes here. So maybe we shouldn't do that. -1, okay. That way, if we have 6 total, if we have 7 shapes, which is what our debugger says, 0, 1, 2, 3, 4, 5, and 6, then we take this and we say random.randint between 0 and 6, which will return to us a number between 0 and 6 inclusive. So that is going to represent either a 0, a 1, a 2, a 3, a 4, or a 5, or a 6. So let's try this out. This seems reasonable to me. So let's try doing this. Random.choice self-shapes? Okay, that's interesting. So you're saying we could potentially do something like this. Random.choice self.shapes, like that? Let's try that. I've never seen that before, but I believe it. Let's try it out. So again, we have to stop the running of the program and we're going to reload it. Aha, we already see a different shape. Cool. So let's keep going here. Ryan gave us the suggestion of random.choice. And let's see. This looks good to me. We already fixed that bug. Cool. Let's see if all of our other bugs are fixed. Nope. Our computer still dies. Our execution still dies. So now we see a different thing that's problematic. What's the problem here? How do we figure out what the problem is? Let's see the stack trace. Okay. So this is going to be super important here. Okay, before we do that, Liam said, let's remove the random int for cleaner code. Great point. We're not using random shape, so let's delete this line of code completely. I deleted it using command delete on Max. That deletes that entire line of execution. Cool. So now we're seeing that in the stack trace, we're seeing issues where this is where it's having problems. So let's click on here. It says 408 is having problems. So for X and X range this, for that, delete this, delete that. Okay. And what is the actual error? It's a key error 019. So 019 doesn't exist right now. Okay. So let's set a breakpoint here and re-execute our program. Okay. It's running the code now. All right, so we're done with this breakpoint, right? Let's get rid of it. We figured out what that code was doing and we don't really care. So let's play some Tetris. It's gonna be fun. Okay, so at the end of this, this should clear the entire line of code, which should trigger our breakpoint basically. Aha, okay. So this is triggering this breakpoint. We already said to do Shrestha is this problematic. So we are already onto something weird here. And what did I say last time about hard-coded numbers? Probably problematic. There might be issues here. So now we say for X in our range for our width. So X is going to represent 10, which basically represents every single column that it's going to be, the 0th column, the first column, etc. If XY is in self.grid, we undraw 0y, and then we delete it from there. Okay, so let's keep going. So for this loop, if XY is in self.grid, so first of all, let's check our grid. Our grid has all of these numbers. What do these numbers represent, possibly? And I'll pull our code over here so that we might be able to see the coordinates a little better. Each box that is filled. Okay. Yeah, so this could represent each block that's filled. Again, 0 is all the way at the top, 19 is at the bottom. So let's check. 0, 1, 2, 3, 4, 5, 6. 619 might be this block. So should we see 618 in here? We don't see 618, which is good. But we should see, for example, 718. So 718 is here, which represents this block. So that sounds right, each block that's being filled. So if we go through and inside of a delete row, we go through and we say, okay, so for each line XY, we're looking at this one, that one, that one, this one, that one, that one, that one, that one, that one, and that one. Are we deleting all of these? Is that what's happening? Let's take a look and do a step over. So we're doing 0y.undraw. I'm assuming undraw just takes it and physically undraws the actual square, deletes it from the grid. And that's what delete does, probably represents our grid, our model of it, not just the UI, and deletes it from there. So 019 doesn't exist, right? Or wait, 019 exists. 019 should exist, and it's right there. So let's step over that. It should delete it after we do that. So now for X in the new range, is 019 in here? It's no longer in here. So let's keep going. If X comma Y is in self.grid, so 0 comma 19, if that's in the grid, or sorry, now we have 1 because we did for X in range. So now we say 1 comma 19. Do we look at 1 comma 19? It's in the grid. So let's delete that. Okay. I don't know what happened there. Let's keep going. So it deleted that. And then, oops, my execution died somewhere. But basically, we're going to see 119 in there. Then we're going to see 219. So 219 is going to be there, and 319, etc. But the problem here is that we're doing 0 here instead of an x here, right? So we're always checking 019, and we're deleting 019 after checking 119 up here. Does that make sense? Does anybody understand what is happening? Raise your hand if you're confused about this line of code and why it's being problematic. Okay, seems like most people are on the same page, or everyone is, according to the fact that no one raised their hands. But yeah, basically, let's write this out in comments. So we're going to check x goes from 0, 1, 2, 3, all the way to self.width. And then we're going to check if 0, comma 19 is in self.grid. And then we're going to check if 119 is in self.grid, 219 is in self.grid. And then this line here, this delete, is actually going to delete 019 over and over. So that's really, really problematic, right? We're going to keep deleting 019 after only checking if 119 is in the grid and 219. So that's the problem, right? And 0, yes, is the first row, or 0 is the first row on the top, not the bottom. So 19 is the bottom row, according to this code. So how do we fix this code right now? How do we make it so that there are no errors in this? Anybody have thoughts? Raise your hand. Okay. Yevgeny said change this 0 to an x. So is that good? Good to go? Also the 0 at 408 to x, okay? Cool. Let's try doing that. Let's just run through it, see if this works, and see what happens. Okay, I'm gonna keep playing here. Okay, so after this, it should clear the entire line. Aha, it does clear the entire line. Okay, let's try putting this down. Okay, this all looks good to me so far. And let's just play a little more to see if this works. I don't know where to put this. Okay, everything looks good to me so far. I actually thought that we had one more bug, but I guess I forgot to add that in. So we're good to go. So we found some bugs using breakpointing and actually using these different techniques in order to find the bugs that we had. Cool. Sounds good to me. When you have the chance, can you share with us why you think try-catch blocks are important and why? Sure. So try-catch blocks are used a lot in industry. They're not wonderful. You want to catch the bugs before they happen. Try-catch blocks basically say, try this code, and if there's an error, then throw an error, like handle that error somehow. It's really important for certain things that throw exceptions. For example, if you're logging to a database, for example, it might have an IO stream exception. You can't avoid that. Certain times you're just going to have a connection that dies. So let's come up with an example. Let's say we want to, after we run through Tetris, we want to write out these results to a database. So maybe the person who's playing Tetris doesn't have internet access. Maybe they're in airplane mode. You might surround this database call with a try catch where you say like internet not available exception or something like that. So you're going to say, try writing out to the database, catch the error that might happen if you can't write to the database because there's no internet. And then you want to handle that error instead of just crashing the entire program. You want to be able to say that, for example, there is no internet, and that's why this is erroring out. You might want to present that error to the user, or you might just say like, let's cache this for later so that we can push it out to a database later. So that's why try catch blocks are important and unavoidable. But you don't want to have a bunch of try catch blocks, especially if they're like generalized try catch blocks where you're just like catch any exception and just silently fail. Because most of the time when you have an exception, you want to understand why you're getting the exception and under what situations those exceptions are happening. Cool. So going back into our exercise, obviously we ran through two very, very simple bugs. This code here, from what I believe, once you fix those two bugs, I believe there's still a third bug. So try going to that GitHub. You don't have to do that now. It's an optional take-home assignment. If you do it, I will give you a virtual high five. But if you end up doing it, I think there is an optional third bug in there. You can clone this GitHub basically and try to trace through and see if you find that third bug. If there is no third bug, then my bad, but I thought I introduced the third bug in there. So try using those debugging techniques on your own to try to find that bug as well. All right, that was my part of the lecture on debugging. Any questions on any of the debugging techniques that we talked about, specifically about using breakpoints? All right, no questions? George?
I have a question. Like, is it possible to like, if you have like a loop, is it possible to say break like halfway through the loop or like when I is equal to like some value like that? Or do you always have to break at the start of the loop?
Yes, so this is an advanced debugging feature. Let me just run through it really quickly. It's called conditional breakpoints. Let me see if I can figure out how to set that up here. So there are some other things that I want to discuss. These are more advanced techniques, but yes, it is possible. Let's go through one more of these and then I'll show you what I'm talking about. So now we're getting into more advanced topics, but that's okay because I think debugging is super important. Okay, so this should trigger this breakpoint. There are some awesome things that we can do. So one thing that we can do is, let's see if I can find the conditional breakpoints. I don't see a conditional breakpoint here, unfortunately. Right click on property, condition. So you want to break, let's say we only want to break when x equals 3. So you write this as regular code. Thank you, Liam. So you're going to write a condition of x equals 3. And this is going to be this conditional breakpoint. So we have this question mark here, and it says the condition is x equals 3. So now, if we keep going, it's only going to break when x equals 3. So that's the magic of a conditional breakpoint. You can right click on it and specify when you want this to break. And the other amazing thing is you don't even have to have it be equal to x equals 3. You can say self.state or like current block. I don't remember what we called it, but you can say current block equals I shape or something like that. So that's the beauty of it. You don't even have to have it be tied to X and Y. You can look at the entire state of a computer and an execution and say that is the condition that is actually going to be on it. Fun fact about this, we had a new engineer on my team and I was going over debugging pretty much this entire talk with that new engineer on my team. And I went over it with everyone, not just that new engineer. And some of the most senior engineers on my team didn't know how to use conditional breakpoints, which was awesome because I taught them how to use conditional breakpoints and they were like, this is amazing. And they like went through and actually used the conditional breakpoint in their workflow from there on out. And they were like, I do this every day now to trace through different loops. So this is a super, super powerful feature. And then one more thing that you can do, which is really cool, is you can keep track of your own variables here. So let's say you had some variable like self.grid that you wanted to look at. Sweet. Now we can just type that in and take a look at what self.grid looks like. You can also always look at something like length of self.grid. And maybe you want to trace what the length looks like. If you don't want to look at it forever, you can also look at something like, that wasn't good. That's not what I wanted. You can also evaluate it as a one-off. So you can do length of self dot height. So that's not going to be a length. It's actually going to be self dot height. And you can just be like, what is that equal to right now? It's equal to 20. So you can do that permanently through adding a new variable here, or you can do that temporarily just as a one-off right there. That makes sense? Parallel programming, not, okay, so to be totally honest, I'm not sure about how to debug parallel programming. You can do thread-based debugging, but for the most part, for thread-based things, I end up just doing, I put a breakpoint in there. If it's triggering correctly, that's fine. Otherwise, you might be SOL and you might just have to set up some print statements. So that might be what you're tasked with doing, unfortunately. So yeah, this is the power of debugging. This is the beauty of what we can do when we use the computer for all that it can do. So let's kill that and let's jump back in here. Second half of class today, I'm going to be talking about testing. But before we go into that, do we have any more questions on debugging? Yes. In Alicia's Tetris, can we assume that the program will clear 2 or more lines as well as it does clear 1 line? Maybe. I don't know. We haven't looked through that. I honestly don't know that code, but that should be the expected behavior. But if that's a bug, then yeah, that would be a bad bug, and we should make sure that we fix that. Instead of threads, you could use conditional breakpoints. Yeah, you could do conditional breakpoints, but mutex is still weird there. Don't worry too much about parallel programming. At least in my class, we're never going to deal with that. Not sure how we would do that. Can I use a can of RAID on my computer? Does that count as debugging? Sure, if you want it to. When do we use the command line for debugging? We might use the command line for debugging if you have a command line debugger. So certain languages like Perl, you have to do a command line debugger basically. So in Perl, you would run something like perl-i-d, and that means do an interactive debugger basically. Fire it up in a command line, and you have lines like next, C is continue, and then O is step out, stuff like that. Yeah, it's like the GDB debugger. You might just have to do it on the command line, but these things do the same exact thing. Next means end, C means continue, O means print, means step out, P means print. So you might do something like print self.shapes, something like that, and that's going to print out the length of them. So if you use an IDE, it's going to be built in for you, but every language also has a command line interface to do this. You just have to figure out how to do that, and I've never done that except in Perl, but yeah, it's just the same exact things basically. Cool. Last 10 minutes, obviously the most important part of this was debugging, but we're also going to be talking about testing. So partner exercise 2. Talk to someone in the class and talk about what are possible ways that we can test our Tetris code. What are possible ways that we can test more complicated projects that have a backend? Maybe we have Tetris online, not just a one-player game, but you have multiplayer Tetris or something like that. So how would we think about testing this code? All right, let's come back together. Christiana, if you are comfortable, would you mind explaining how you would test Tetris?
When you say test, do you mean like running it and seeing if it plays how it's supposed to play?
Whatever you want. Yeah, that is one way to test it. How would we do that?
So if you can either just run it like how you would normally run it and see if it hits any um if it hits an error or something like that.
Okay.
You can debug it and run it that way by like stopping it at breakpoints to see what happens.
Okay. And what are some tests that you would actually run through in your Tetris code?
Like the ones that we went through earlier, like getting different shapes.
Okay. So getting different shapes, clearing lines, that makes sense to me. Vaishnavi, did you have something to add to that? She just messaged me privately. I can read it out loud. You can have various modes and various functions that auto test different multiple situations. So maybe you have actual lines of code that run through an execution and actually test whether it's doing the right things or not. That's a great idea as well. Maybe we automate the testing so that we don't have to do it manually every time. Tien had an interesting solution, which was release the beta version of the game first and just get feedback from other people, crowdsource the testing of it. That's a very common tactic, and it's not a bad one. You want to make sure it's robust and safe to use, and then once you can do that, you can crowdsource it. Yeah. Yeah, that's exactly what Tesla did. So obviously Tesla is not going to release autopilot before making sure that it works properly and doesn't kill you. But once they've made sure it doesn't kill you, they were like, cool, there might be some bugs on the map, but the more that you guys drive, the more information we get about whether or not it works. Test-driven testing, absolutely, where you think of cases and account for them inside of the game. Absolutely. So Vaishnavi brought up that excellent point, which is you can think of the tests first and then write your code and then test your code after that. In reality, like in industry, we don't often do test-driven development because yes, exactly, because of Agile. Agile makes it so that we're changing things all the time. So like test-driven development is this like pie in the sky idea that we would love to strive for, but it's so hard to do in actuality because your specs are constantly changing. One week something might be the right thing to do, and the next week it might be different. So yeah, test-driven development, not the best practical example, but it is like a great idea in theory. Cool. Awesome. So let's go into types of different tests. We won't be covering these today or even in this class, but you can feel free to ask me about these different test cases. I have written all of these different test cases in my career. Facebook doesn't test that much, so I don't write much of these tests anymore. The only one that I'm truly an expert on is going to be UI testing and end-to-end testing. I haven't done too much I haven't done too much unit testing or mock. Okay, no, I've done all of these pretty well. I've done a lot of these at Facebook. So we can talk through all of these as much as well. Facebook doesn't test that much because there are no life critical things at Facebook. Facebook prioritizes moving very, very fast. And the theory is, okay, let's say the app breaks for a lot of people, then what we end up doing is just internally doing what Tien said, where basically you just crowdsource the testing to 50,000 Facebook employees and 10 million alpha testers. So once you do those, then basically you'll find most of the mission critical bugs. The small things are going to be actually problematic. Now this could result in huge problems like Eric just pointed out. Move fast, break democracy. Yeah, that could happen because someone at some point didn't think about whether like the consequences of what they were working on could actually have huge, huge repercussions and ripple effects that end up breaking democracy and allowing Russian interference. So testing is important. That was a huge gap. And after that happened, Facebook was like, we need to make sure we invest on testing in civic infrastructure. So we have to make sure that we're looking at what ads are actually coming into the system and stuff like that. So yes, that was a huge mistake not to test in that case. But for the most part, little things like the profile or the navigation or, I don't know, starting your Facebook app, if those break on Facebook, they're not going to literally hurt people or result in lives being lost. Whereas somewhere like Tesla or Uber or Google Maps, those are actually going to result in people being hurt if like something goes wrong. So those places are going to invest more in testing, whereas Facebook invests more in speed for the most part. Of course, things are changing because of recent problems, like when democracy broke and Russians were able to interfere in the election and stuff like that. So we are also investing more in that as well. So here are the different test cases: unit tests, mock frameworks, integration tests, UI frameworks, end-to-end tests. There's a lot of different problems here. And yeah, there's a lot of different tests that you can have. I'm not going to go over them, but I've left definitions here. So you can read through them on your own. I'll upload these slides. I updated these slides, so I'll re-upload them to Canvas after this lecture. But one more thing that I wanted to go over is, what if you don't have time for these? You should at least be manually testing your code by looking at what your code does under certain scenarios. So this is what Cristiano was saying. Leave your test cases in your code, but just add some test cases until you are 100% certain your code always works, or you identify gaps in them. So let's think about how we would manually test Tetris. So leaving it up to chance to see what shape we get might not be the best. So maybe we should add something called create new shape debug only that specifically drops the same shape over and over. Squares are really easy to use, so let's just keep dropping the square over and over. Then we can replace all calls to create new shape with create new shape debug only, and then just forcibly test it a lot, over and over and over. Would it also be considered good testing to have test cases that are intended to fail? You can have test cases that are intended to fail, but that would be the success state. So there are certain test frameworks like unit testing. You can say expect to fail. And then if you expect it to fail and it says yes, then your test will actually pass. Does that make sense? So basically you're expecting that it will fail, and if it passes, then your test actually fails. Does that make sense? Cool. Awesome. So let's actually go through our exercise. We have about 2 minutes left, and make create new shape debug only. So we have this create new shape, and now we want to do create new shape debug only. The quiz has already been posted. It's in the first slide. So now we're going to do create new shape debug only. And then this is going to return a specific shape that we want. So instead of random.choice, we want self.shapes. And then we want to look at a specific shape, which is the square shape. So that's the O shape, which is the third one. So we're going to say 3 here. So that looks right to me. Do I have an issue here? Let's see. This code is unreachable. Why is this code unreachable? Let's try this. That's not what unreachable means usually. It means that it literally is not executable. But yes, you're right, I don't call that. So we're going to look for create new shape. And then we're going to replace all of the calls with create new shape debug only. So let's do that. Awesome. So that looks good to me. Let's try running this code real quick. Okay, 523 is problematic. All right, I'm just going to delete all of this. Hopefully that helps. Not sure what is happening here. This is very odd. I think my code is written correctly, but it seems to not like it so much. I think there were problems with indents because Python is really, really annoying. Yep, it was indents, which is super annoying. Okay. So now we're going to run this code. Is that it? Okay, I'm honestly not sure what is happening here, but basically you get the idea. We can basically write this new test code only. And yeah, it's some like spaces versus tabs thing. Don't worry about it too much, but you can do this on your own. Basically create this new function, use squares, and then you can use that to force test things. So instead of random functions or whatever, you can basically, instead of using random shapes, you want to control the things that you're testing. So first, let's test this out manually. If you don't have time to write the manual, if you don't have time to write automated tests, create these debug methods. Leave them in your code. Leave a comment that says, only used for testing. Will always drop a square shape. And then use that to test through your different methods, basically. Cool. So that is one way to test different things that you want to do, and you can go through that. If you have more time, the best thing that you can do is add in unit testing, mock testing, integration testing, UI testing, and then do your end-to-end testing. So I recommend doing those things if you have the time for it, but in class, you're not going to have the time, so don't bother doing those. So just go ahead and do those manual testings using those mock methods, basically. Cool. So that is it for today's lecture. Thursday, we're going to be back to algorithms, and Thursday, we're going to be talking about minimum spanning trees. So that's going to be at 10 a.m., same Zoom link, and it's going to be required for section 6, optional for 2 and 4, and the daily quiz will be required for all sections, for all lectures. I'm going to keep stressing this. It's like the 7th time I've said this. You are required to turn in a daily quiz. Everybody is. Even if your lecture is optional, you still have to turn in your daily quiz. Today's daily quiz, as a reminder, is to upload a screenshot or picture of your planner that proves you have all 10 remaining lecture dates added to your calendar. And you have to say which ones are required for your section. So make sure to upload that picture, and then you will get credit for attending this lecture. Excellent. Any more questions that we have? Sorry for holding us 3 minutes late. Awesome. Yeah, just feel free to, if you have any more follow-up questions or anything that you want to talk about, feel free to hop into my office hours. They're going to be from 1 to 2:20 today, I believe. So feel free to hop into those office hours and I will be happy to help. Good luck on project 2 and have fun doing code reviews, whose instructions I will be posting very soon. Goodbye.